Hello everyone, this is the video lecture for Pre-Calculus section 5.6, Modeling Harmonics. So, in this section we're going to do applications of what we already know and what we've already seen. Let me go ahead and show you some of these questions. Pretty easy. 008. So I got y is equal to 2.1 sine of 3.8t. And they're wanting some information from this. First off, what's the amplitude? Well, 2.1. What's your period? Well, it's 2 pi over b. B is that 3.8. Again, you don't have to simplify in WebAssign. Frequency is always 1 over your period. So there's like a formula for you. There's a formula. But in this particular case, you just basically flip it. And you get this guy, yet again, you don't have to simplify in WebAssign. To draw a graph of this, super easy. It's a sine wave, looks like that. My period, again, ends at 2 pi over 3.8, wherever that is. That's a little less than 2. And its amplitude is 2.1. That's it. 5.6.009. So I've got y is equal to negative 0.25. Make sure that looks like a 5. Cosine of 1.25t minus pi over 3. So I need to alter this a little bit. I'm going to be pulling out a 1.25 to the front. So 1.25 times t minus, by front I mean like the front, like right there. And then so I'm going to pull out a 1.25. 1.25 times the 3 both in the bottom makes a 3.75. So I just did that math ahead of time. This is not anything new. We've done this all before. Notice that we got a negative in the front, so it's going to be that vertical reflection. We got our amplitude, our B for our, to define our period, which I'll go ahead and do right now, I guess. 2 pi over the 1.25, whatever that is. So there's my period. My amplitude, there it is, I guess. And again, don't include the negative sign. Amplitude is always positive, absolute value stuff. Frequency is the 1 over the period, so 1.25 over 2 pi. That was easy. And when you're graphing this, remember that negative in the front. I have to shift it by this pi over 3.75, which is less than 1. It's a cosine, so generally I start a pi and then I do this, right? And then I would say that this distance here was that 2 pi over 1.25. Cool. But that's the cosine. Remember now it's negative cosine, vertical reflection, so it's actually down here. And I do this instead. There's your graph. That's it. Next question. These are kind of interesting questions. So they're kind of like word problems, kind of 014. It says, find the function where, and this is important, this part, okay, the displacement at 0, no, I'm sorry, displacement of 0, at t equals 0. The amplitude, so comma, amplitude is equal to 26, and the period is equal to 2. Go ahead and find it. So it'll say y equals and find the function. Well, when it says this displacement of 0 at t equals 0, what they're actually saying is sine. If you notice the sine, it does this, right? At 0, how high is it? 0. So this is my y value at the x value. Okay, that's kind of what they're saying. A period equals 2, so that's, again, my period is 2 pi over b. So 2 is equal to 2 pi over b. To solve for b, move some stuff around. b is equal to 2 pi over 2. Cancel, leaves you with a pi. So that was easy. Amplitude 26. That's easy too. So 26 sine of pi t. They didn't talk anything about shifting or anything like that, so no need to do any of that. 56018. Find the function. Same as last time. They say this time we have a maximum at t equals 0. Amplitude is 35. Period equals 4. When they say maximum at t equals 0, they're saying cosine. Again, look at the cosine. It looks something kind of like this. So at 0, we have a maximum. Look at that. Period equals 4, so 4 is equal to 2 pi over b. Again, move these two guys. B is equal to 2 pi over 4, pi over 2. Okay, so that's going to be my b. So y equals, what goes in the box? 35 amplitude, cosine function, pi over 2 times t. That's it. 56024. I've got, this one's strange here. I don't even think they give the formula. They might. But k is equal to 0.7. C is equal to 3. They say I have a period of 3 pi. And then they want you to use this big old formula here. Again, I can't remember if they actually included this in this problem or not, but I have to give it to you, so here we go. That looks like a W, but that actually is an omega. That is an omega. It has little to do with what we're actually doing, because basically I'm going to think of it as a B, because I've been calling it B for the past forevers. And so, let's start with our period here. 3 pi is equal to 2 pi over b. I mean, you could put an omega there. I just don't think it's worth it. Switch things around, just like we've been doing all for this thing. Pi's cancel, and you get the 2/3 for b, or omega, I guess you can say. K, C, everything else is fine. So y equals 0.7 for the k, e to the negative 3t, and then times cosine of 2/3 t. Cool. Now, what is this thing? Well, first off, let me just graph it for realies. The way they're going to have it, 0.7 is where we're starting over here, and it goes down. It goes down kind of like this. Their graph ends at around 2, and it's pretty close to the bottom there. It's just going down, kind of curvy, kind of curves. It's not a line, it's more like a curve. But in reality, what this is a dampening function. What you do is you start at some place, and it kind of dampens it over time until it's about 0. So it takes that harmonic and it keeps going. Think of like a grandfather clock or a metronome. And so you got you tick, tick, tock, tick, tock, tick, tock. Well, I mean, you set it, right? But it won't be in perpetual motion for like the next 100 years. So, you let it tick-tock for a while, and eventually it just runs out of tick-tock. It just stops. So that's what this is going on is, tick-tock, 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 tick-tock. And then basically it's just going to end up 0. Another idea of this is, say, take a basketball, and I'm drawing something like a basketball, and you bounce it on the ground, and it bounces, 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 and it just kind of rolls. And eventually it even stops due to the horizontal friction even. So that's kind of what's going on here. Dampened. We got 2 last problems. I got 56045. So this is the tides problem. Apparently that's important if it gets a name. There's a 1 12-hour period which starts at the mean sea level, okay? It rises and falls by 17 feet each. So rises 17, falls 17. It sounds better. I just was being lazy there. Okay, go. What's the function? Well, 12-hour period is actually, it means that's the period. 12 is equal to 2 pi over b. Okay, so b would be 2 pi over 12. B is equal to pi over 6. So already we can get that much. When it says starts at mean sea level, what they're saying is sine. The reason why, yet again, let me show you, does this, right? Well, that's the average. It starts right there in the middle, right in the average. Rises and falls, that's going to be my amplitude. And so 17 sine pi over 6 t. That's what you type. That's what you get. What the actual answer is, like, I'm sorry, that is the actual answer. What the graph looks like is there's a 12 and there's a 17. I can't remember if that's part of the answer or not. 5, 6, 0, 5, 9. So this is the tuning fork problem. I remember this one for sure. Amplitude is measured, but then 5 seconds later, it's half of its original value. Find C. And you're like, what is going on here? The tuning fork problem. So a tuning fork, just kind of reminding, telling you, teaching you, it looks something kind of like this. And what you do is you hold it down here. So you put your hand around it right there. And then you like bonk it on something and it vibrates. Zing, zing. And it just goes. Notice it just goes away, right? Over time, it goes away. It's dampening, right? So, okay. So that's the idea. They measure the amplitude here at, say, like 5, but then, like, I'm sorry, they measure the amplitude, not at 5. Sorry, my bad. They measure the amplitude, A. But then, like, 5 seconds later, I don't know, 5 seconds later, it's like half as tall. So right here and here. So, like, that's A, and this is half of A. That's what's going on. So, what is the C that would make that work? Now, what they're actually referring to, if you go way, way back, way, way back, way, way back, they're referring back to this guy right here. What's that C right there? What's actually going on is that you don't even need the sign involved at all. You don't have to use any trig on this. It's E negative CT that you're comparing. I believe that's just your amplitude. It's your it's the scale of your amplitude. So then you got 100% at this point. Hold on. When t equals 0. And then you got half of that amount when t equals 5. Now, E is that 2.71828 kind of stuff. It's just a constant. It's interesting because e to the 0 is equal to 1. That didn't really help me at all. This is the only thing I got, solve for C. So what do you do to get rid of the e? You ln both sides. I don't know why this is over here in trig land. I mean, it's harmonics, I guess. So I got ln of 1/2 is equal to negative 5c. Solve for c. Divide by the negative 5. Now you're thinking, oh, it's going to end up a negative number. No, because ln of 1/2 is also negative. Two negatives should make a positive. I'm going to type that in real quick. ln 0.5 divided by negative 5. And I got a 0.138629. And that is exactly right. There you go. Okay. That's it. That's all I got. We're done with all of the Chapter 5 stuff. If you have any questions, let me know. I know a lot of this was informal. Some of it was kind of fast, but I'm just wanting to show you how to do it and where to get started. And, of course, you always got the Ask My Teacher button. So send it right to me. I'll reply, and we can talk about it. There's no way I can actually do every single one of these questions, but I think we're doing enough that you can at least kind of see what's going on with this. Thank you very much. Have a great day.